Wow. Before we went on break, we were talking about what? Reducing agent. And now it's time for us to discuss what? Oxidizing agent. Welcome back to Chemistry Meal. Okay. Let's look at oxidizing agents. An oxidizing agent is a substance that causes what? Oxidation. Any substance that will make oxidation to occur, that substance is called what? An oxidizing agent. So any substance that will bring about oxidation of substances, of other substances, that substance is what? An oxidizing what? Agent. So an oxidizing agent will oxidize other substances and become what? Reduce. So an oxidizing agent will oxidize other substances and then become what? Reduce. So the duty of the oxidizing agent is to oxidize other substances. So as it's oxidizing other substances, itself will become what? Reduce. So an oxidizing agent will undergo a reduction in the course of a chemical reaction. So in a chemical reaction, an oxidizing agent will undergo reduction. That's why in redox reaction, you will see that oxidizing agents will be used in writing the reduction half what? Reactions, that's half equations. We're going to get there. When we come to redox reaction, we're going to see it. So an oxidizing agent has capacity to do what? To oxidize other substances. So oxidizing agents have capacity or ability. Oxidizing agents have what? The ability to oxidize other substances. They have that ability. They are agents of what? Of oxidation. So they have ability to oxidize other what? Substances. So they have the ability or the capacity to oxidize other substances. But something will happen. As they are oxidizing other substances, they will be undergoing what? Reduction. So an oxidizing agent will oxidize a substance and then become what? Reduce. Just like we saw in reducing agents, they will reduce substances and then become what? Oxidized. Yeah. They will reduce substances and become oxidized. That's for reducing agent. But oxidizing agents will oxidize substances and then they will become what? They will become reduced. You must understand this. You must. So oxidizing agents are good electron acceptors. So oxidizing agents are good electron acceptors. So any substance that has high ability to accept electron, that substance will be what? A good oxidizing agent. So oxidizing agents are good electron what? Acceptors. So they have high tendency of accepting what? Electron. In other words, we may say that they have to be electronegative. You know that term in chemistry. The ease by which an element or a substance accepts what? Electron. So oxidizing agents are good electron what? Acceptors. So they can accept electrons easily. They can accept electrons easily. We saw in reducing agent that they are good electron donors. They can donate electrons easily for reducing agents. But oxidizing agents are good electron what? Acceptors. So they have ability to do what? Accept what? Accept electrons. So it means that the oxidation action of what? Of oxidizing agent is carried out by the oxidizing agent through a process of what? Accepting electrons. So how does an oxidizing agent oxidize other substances? By accepting electrons. How does a reducing agent reduce other substances? By donating what? Electrons. So when a reducing agent wants to reduce a substance, it will just donate electron. When an oxidizing agent wants to oxidize a substance, it will just do what? Accept electron. So oxidation occurs by an oxidizing agent accepting what? Electron. That's how it happens. So an oxidizing agent will accept electron in order to oxidize other substances. In other words, an oxidizing agent will accept electron in order to become reduced. Because when it's accepting electron, it's oxidizing other substances. That acceptance of the electron will make the oxidizing agent to become what? To become reduced. Will make the oxidizing agent to become what? Reduced. So the oxidizing agent will accept electron in order to do what? Oxidize other substances and become what? Reduced. A reducing agent will donate electron. Why is it donating electron? It wants to do what? Reduce other substances and then become what? Oxidized. So that's what happens. So if you now see an oxidizing agent is accepting electron, the electron the oxidizing agent will accept must be donated by the what? Reducing agent. So that's why in every reaction involving an oxidizing agent, there will also be what? A reducing agent that will donate electron to that oxidizing agent. So that's how it works. Oxidizing agent will do what? Accept electron. That acceptance of electron by an oxidizing agent will do two things. That acceptance of electron will make the oxidizing agent to be reduced and make the other substance that is accepting the electron from to be what? Oxidized. So the donation of electron by what? By a reducing agent will also do two things. When a reducing agent donates electron, that reducing agent will make the substance that is receiving electron to be what? Reduced. And itself that is donating the electron will now become what? Oxidized. I believe that makes it very, very clear. Okay. So how do we identify an oxidizing agent? How do we? So we say that oxidizing agents are good electron acceptors. They are good electron acceptors. They accept electrons easily. So to identify an oxidizing agent, we use the same principle that we mentioned when we are talking about reducing agent. We use the principle of change in oxidation number, of change in oxidation state or number. Oxidation state. The substance containing an element whose oxidation state decreases in the reaction is the oxidizing agent. So, in the course of a chemical reaction, the oxidation state of the oxidizing agent will do decrease. So that substance that we contain or that contains the what? The element whose oxidation state decreases in the course of the reaction, that substance is what? The oxidizing agent. I used a particular example previously. Let me use another one. Let's say I have this reaction. I have the iodide with this, for example. Let's say, example. We have the iodide plus this, and this become this plus this. Now, The question is, which one is the oxidizing agent and which one is the reducing agent? This is actually the reducing agent. And this is the oxidizing agent. Somebody may be wondering how. Okay, let's see. What's the oxidation state of what? Okay, let's answer the question before stating it. What's the oxidation state of the iodine here is -1. Oxidation state of chlorine here is 0. Oxidation state of chlorine here, -1. Oxidation state of iodine here, 0. Now you notice the oxidation state of iodine just increased from -1 to 0. You remember -1 is less than 0. -1 is less than 0. So from -1 to 0 is increasing oxidation number. And we know that the substance whose oxidation number will increase is the what? Reducing agent. Reducing agent. So that's why this is the reducing agent. The oxidation state of chlorine decreased from 0 to what? To minus what? To -1. And we know that the substance whose oxidation number will do what? Decrease is the what? Oxidizing agent. So what are the examples of what? Of oxidizing agent. Examples of oxidizing agent. So, examples of oxidizing agents. What are the examples of oxidizing agents? Quickly, there are so many of them. I can talk about the halogens. So I can talk about chlorine is an example. We know that HNO3, triazonitrate 5 acid, is also an oxidizing agent. But we have the ones that we use always in most reaction, potassium tetraozomanganese 7. The aqueous solution of this in acidified form is an oxidizing agent. Then potassium heptaozodichromate 6, the acidified solution of this is also what? Oxidizing agent and other substances. So these are the examples of oxidizing agents. Now, in part 9, we are going to just look at the test for what? Reducing agents and oxidizing agents. It's just going to be a very short video before we now introduce the concept of what? Redox reaction. Remember, our business is to make sure that you excel in your exams. No matter the exams you are writing, be it WAEC or UTME, our business is to make sure that you excel. Make sure you take your studies seriously. Study your mathematics, study your physics, study your chemistry, study your biology, and every other subject that you may be taking in your WAEC, that's your SSCE, or in your UTME. Remember, I'm still your friend and your brother, Engineer Ike Okechukwu. I love you.